Hello, we are Team Insight Works. Our solution, Delivery Confidence Assistant, helps teams see delivery risk early, understand why it's building, and act before tasks slip. The challenge is not just spotting slippage after the fact, it's giving teams earlier warning, explaining planning and delivery behaviour, and pointing them towards the right action. Our team is from Rolls-Royce and has a range of skills including project delivery knowledge, data analytics, and programming skills. Its members are David Belshaw, Kieran Baxter, and Farron Bates. The problem is not about a lack of data, it's about a lack of usable insight. Dates move, pressure builds, and standard reports rarely tell people what to do next. Our delivery confidence assistant provides an early warning, explains risk drivers, provides behavior insights to programs and delivery teams, and generates role-specific action to improve performance. On the screen, you can see our user personas and key use cases. Project managers need early warning. Planners need planning behavior insight. Senior leaders need a simple picture of where to intervene. Work center leads need to see pressure and protect priority work. So the assistant answers four things: which tasks are likely to slip, what program behavior looks like, what the work center or delivery team behavior looks like, and what action each role should take now. So how does it work? It's really made of four parts. We do a lot of machine learning in Python. We also create some business intelligence reports in Power BI. And over the top of those, we have an LLM that can answer questions through natural language, and also a playbook-driven agent that creates actions for particular users. So overall, it combines analytics reporting, natural language interaction, and guided action in one experience. Machine learning really is the engine for our product. It does this by using three different types of ML algorithm. We use classification to predict whether a forecast will slip further. We use regression to predict how much additional lateness there would be. And we use unsupervised machine learning to look at behaviors. So how does the model work? We build targets by using historical data snapshots. We engineer features. We look at the time-based split of those features, and then we select the best models. We actually use quite a few models and tested quite a few to get in our solution. We then can make predictions. So we can predict risk, predict the slip size, assign a risk band, understand the key drivers, and provide recommendations. The key result being actionable recommendations with owners, priorities, and status. Here is one of our business intelligence reports. This is the executive summary. It clearly shows the amount of high-risk tasks and committed tasks at risk over time, the work centers with the most pressure, the program hotspots, and also the top intervention queue, so a set of actions that must be taken in priority order to improve performance. This shows you the GUI we built for our lightweight LLM, how we can interact with the data through natural language, through plain English questions. This helps people that don't want to navigate potentially complex dashboards. Here you can see our playbook-driven agent that converts insight into concrete actions for different roles, such as project manager, planner, uh, work center lead, etc. Additionally, we built email notifications into our script if that wants to be used. We think what we've developed is highly applicable commercially. We use open source and widely available tools. We've made sure we've added commentary, markdowns, etc. to make sure people can understand them. And we created quite a lot of documentation. The Miro board that talks about our problem decomposition and product discovery, relationship logic diagrams, and data dictionaries. Our product has been designed to be handed over and scaled after the hack. So overall, we provide a realistic foundation for commercial adoption in a delivery environment. There are numerous benefits from our delivery confidence assistant through decisions, operational, and business. Ultimately, it's all about earlier intervention, better use of people and capacity, fewer avoidable delays, less firefighting, lower disruption, and stronger delivery confidence. On the screen, you can see the judges' questions. To answer question 1, our solution combines task risk, program behavior, and work center performance to spot likely issues early and suggest practical action. It uses signals such as forecast drift, commitment status, time remaining, and capacity pressure to highlight where intervention is most needed. Also, it will improve over time. As more historic data becomes available, the models can be retrained and recommendations refined based on what actually works in practice. For question 2, the solution is built for main user groups: planners, project managers, work center leads, and senior leaders. Each sees the insight and actions most relevant to their role. We've also made it easy to understand because it turns that complex delivery data into clear views, simple explanations, and practical next steps. Question 3. We built our solution on common tools so it can fit into standard company environments and governance expectations. We've also made it adaptable so you can tailor it to different delivery organizations, systems, and reporting standards. Overall, we believe the solution delivers well against the criteria. It provides useful insight, clarity, explanations, really practical value. It uses a good use of data and delivers strong communications. To close, delivery confident assistance helps teams see risk early, understand behavior, and act with confidence. Thank you for listening.